Okay, so this is going to be talking about solving logarithmic and exponential equations. In reality is I'm only going to solve, I think, one example of a logarithmic here. And that's going to look something like this. You have log of 2x plus 1 equals log of 5. They're both base 10, and that's important. They do have to have the same base on both sides. Now, there's two ways of doing this. The pure math way is this. These are equal to each other, so if I take 10 raised to this side equals 10 raised to that side, it has to be true that these two values are equal. We're not used to doing that, but if these are equal, then any base raised to them as exponents has to be equal. But when I look at log base 10 and 10, these are inverses of each other, and they invert off. And what happens is I'm left with basically 2x plus 1 is equal to 5. And when I solve that, just straight up solving, subtract 1, divide by 2, I get x is equal to 2. And you can plug it back in and check it, but that's one way of solving logs. If there's just a log of something on one side equals log of something on the other, you can raise them to the base to get rid of them. But what's really happening, these logs can only be equal if what's here and here are equal. Okay. Now, more importantly, let's look at equations like this. Here I have 10 to the x is equal to 1,000. Now we know the answer to this. The answer to this one's going to be 3. But I want to show you a technique for solving it. And the technique involves property 3 that we discussed. So if I take the common log of both sides, and I could do this for any logarithm, but I'm going to use common log. Property 3 allows me to move the x to the front. So I can rewrite it to be x log 10 is equal to log of 1,000. Now, I can think about, log 10. Well, log of 10 is equal to 1, because 10 to the 1 is 10. Throw it in your calculator however you want to think about it, but this is just a number. So if I take log of 1,000 divided by log 10, I basically get log of 1,000 divided by 1. And log of 1,000 is 3, because 10 cubed is 1,000. Now, if you want, just tune that all out and look at the steps, and you can see what's happening. Now, I seldom use logs, just common log, to solve these equations. The only time is when this is a 10, because log of 10 is 1. But if they get a little more complicated, like this one, I'm going to solve it two different ways, and you're going to get the answer, but you're going to see that it doesn't matter if I use common log or later on ln. So I have 11 to the x equals 745. I'm not doing that in my head. But if I do just take the common log of both sides, and property 3 allows me to move the x down, I now have x log 11 equals log 745. Log base 10 of 11, some number, I don't know what it is, a little over 1, but I don't really care what it is, because I want to get x by itself. So if I look at this here, this step there, if I divide both sides by log 11, here I don't care about the parentheses. Over here it's helpful to put parentheses so you don't screw up putting it in the calculator. I'll get x is equal to log 745 divided by log 11. And at this stage you might want to throw it in your calculator like this. Make sure you have that parenthesis closing it off. Make sure you have logs on both. It has to look just like that. And we should get around 2.76. If I take the same problem and do it with an ln, remember ln is log base e. One advantage to using ln, well, it's 2 letters compared to 3. And when we have e's, they help out a lot. So I do the same step. I'm going to take ln of both sides. Property 3 allows me to move the x down. I don't know what ln 11 is. I don't care. But I'm going to divide both sides by ln 11. So I'm mimicking the steps I did up here where I wrote them all out. But instead of log, I'm having ln. And check it, you get the same answer. So generally speaking, I almost always use ln to solve these things. And this is the reason why. If I look at this one, e to the 3x equals 19, I could do it with log. I'm not going to. I'm going to use ln because ln is log base e. They're inverses of each other. So when I apply ln to both sides, and I apply property 3, I move the 3x down, I get the ln of e right there. Well, ln of e is 1. Okay, because log base e of e is always going to be equal to 1. So in reality, I have 3x is equal to ln 19. It simplified the problem greatly. If I used a log, common log, then I'd still have that there. I'd have the log of e, and then I'd have to divide by that. When you have e's, use ln's. Finish this off, I divide both sides by 3. I get around 0.98. Go ahead and plug it back in and check it. Okay, so now we can start solving more difficult equations. Don't you love it when it says that? Here we go. A little more difficult. 4e to ugliness is equal to 17. Before I start just throwing logarithms at this thing, you have to get the base isolated. So I have to get rid of the 4, so I'm going to divide both sides by 4. Notice I'm not dividing it by 4 and getting the decimal. I don't care what it is. I'll leave it as 17 over 4. I now apply ln to both sides. Again, I do not care what this number is. I do not pick up the calculator till I get to the last step, because when we do story problems, that can lead to rounding errors. So again, I just leave it like that. It's along for the ride. Property 3 allows me to rewrite this as 0.0034. X equals ln e, but again, ln e is 1. So to get the x by itself, all I have to do is divide by 0.0034. I get this thing. It looks kind of ugly, but after you do a few, it's not bad. You have to put your parentheses, though, in the right spots. So that's why here I don't have parentheses. When I apply the ln, I put them, because I know I'm going to be using the calculator. Okay, here's another example. Negative 4 times the quantity 6 to the x plus 2 equals negative 45. Safety tip, I can't multiply these two quantities because this 6 is to an exponent. So I'm going to divide by negative 4. One thing I would do is negative is a positive, so I drop my negatives here. I do the ln. That allows me to move the exponent down, but the exponent this time is a little more complicated, so I'm putting it in parentheses. My goal is to get x by itself, so I'm going to divide by ln 6. And then to get the x completely by itself, I have to subtract the 2. So again, pause it, check these steps out, make sure you believe them, grab your calculator, throw it in there until you get that, then continue on. Here's another log equation. It is and it isn't. If I have a log base 3 to 7, I can set that equal to x and then rewrite it as an exponential, so I get 3 to the x equals 7. And if I just smoke on through this with an ln, it goes very rapidly. You should be able to follow these steps. Now, property 3, divide by ln 3, boom. So that's solving equations in a very fast amount of time. And we'll be using this skill when we hit exponential story problems. So hang in there.